Hi everyone, Dave Thomas here again, and today instead of building a rocket, I'm going to build a launch controller. And this came up with an online question on one of the social media platforms where another user had found this control box on Amazon that had a nice big red button and a key switch on it, and he was asking whether or not this would make a good launch controller. So I bought one of these, and we'll just open it up here. Now this was roughly $10 as I recall. It's not very expensive. And one of the nice things about it is it's rated at 10 amps. So that's going to be far more current than just about anything you're going to see on a launch pad, unless you're doing a really big cluster. Okay, so this comes unassembled here. Okay, so we have this small electrical box, and then we've got the two switches here. Now this should have two of these. These are just marker panels, and I saw a little plate here, and so that this, you can put a little piece of paper in here with whatever you want typed on it, and then this slides over. But there's supposed to be two of them in here, and this is the second time this has happened. So I ordered one of these once before, and it was also missing the nameplate. At this point, I'm not going to worry about it because I'm not going to use the nameplate anyway. But this was kind of a prelude as to the possible quality of this. Okay, so in here, here's the big red button, which everybody thought was really kind of cool. I did as well. I had looked at this before and thought about getting one. Okay, so this is a momentary push-button switch. It is double pole, double throw, which means you can actually control two separate circuits with the same switch here. Okay, and again, it doesn't have a really heavy, high-quality feel to it, but it is rated at what we need it for. So it's rated at 10 amps, and it's going to fit into one of these two holes. Now this one I have questions about because I'm pretty sure that this is not a return switch, nor is it locked. Okay, so I can put the key in and out when it's off. If I turn it on, which I would do if I was using this as a safety interlock, that would be okay as long as I couldn't pull it out. But I can. Okay, so while it's a good key switch, it's not what I would recommend for a safe launch controller. I either want to have one that I cannot remove the key in while it's on, or better yet, one that the key is only on and momentary, so that as soon as I take the pressure off of it, it goes back to the off position. So I'm going to go ahead and continue using this box and the red button, but I'm going to show you some alternatives to this particular key switch. So here's the original again, and I went back onto Amazon once more and found two other possibilities. These are roughly the same size. For all I know, they could be made by the same manufacturer in China. Okay, so this one is just a simple on-off switch, but when it's on the on position, the key cannot be removed. So this would be acceptable as a safety key switch. Okay, and then this one is a momentary key switch. So not only can't you remove the key when it's in the on position, if you let go, it goes back into the off position. And for a simple single launch controller like we're building here, this is my favorite choice. But if you can't find one of these, then at least one that does not allow the key to be removed. Because that's the safety issue here. Alright, so if you're launching, you have your key here, and you have a misfire or something like that where you have to go back up to the launch pad and you pull the key out thinking that you're safe, where this is still in the on position and the wires to the launch pad are still energized. So I'm going to put this one away in my junk box. I'll have some future use for it perhaps. And as I said, between these two I prefer the momentary one, so I'm going to set aside the locking one as well. And now the first thing I'm going to do is just make sure that everything fits. Now as we go to put the switches in, on this style of switch here, and it's found on both the momentary and the contact open, is that it's got this yellow part here with an arrow. And what that does is it releases the core from the switch. So this should normally be over here on the left side. What happens is if we click this over, then we can lift that core out. And this is good if you need to change the key. Okay, I don't know how well the manufacturer does with different types of keys and such, but that's what this is for. It allows you to release the key core from the switch itself. Now when we put this together, we will have to release the core, turns out. So this has a screw here, but that is only for changing the depth of this depending on how thick your box is. Okay, so the top part does not remove like it does in some switches. So I'm going to take this like this, pull that out, and then this will go in here. Okay, and I can put this back in. Alright, and then turning it over, you may need a little tool, screwdriver. I'm just using a rod here. And just click that back over. Okay, and then the collar that's on this can be brought down. Okay, now that still looks kind of ugly. It's because I put it in wrong. To put this into the box, we first have to release the key itself from the switch, and then we need to undo this nut here. Okay, there's a little washer there. It looks like that should be up against the rest of the switch there. It's just acting as a seal. Okay, and I'm going to put this into my box. Okay, and it doesn't matter which side you put it in. You can even put it so that it goes like this, which is the way I'm going to do it, and I'll have my safety key here and my big red launch button right there. Okay, so once you've got that, and you don't need to keep the key in there, I'm going to go ahead and take that out. And then the retaining nut here simply goes up, and you can finger tighten that so that this doesn't go anywhere. And now we can put the switch mechanism itself back on and click that into place. Okay, so that should all fit like that. Now I'm going to take this completely apart again once I've got everything figured out. Okay, so here I'm just checking the depth since I do have a different switch in there. Alright, for the push button switch, this is similar, but in this case the switch button itself comes off. Okay, and here we have two rings. So one of these goes on here. Alright, and we'll sandwich in between the box itself. And then the big red button here also screws on like that. Okay, so to put this on properly, alright, we first have to see where we want everything. So first thing to adjust is going to be this lower nut, and then that will fit up in here. Now here I've got a problem where the lock release here is going to run into this. And we're just going to finesse this around a little bit. Okay, it will fit, just barely. Alright, and there we go. Okay, so I want that neck up. And then we've got another little seal here. It's going to go like that. Actually, I think that seal is going to go on here. Neither one of these switches comes with any instructions, so you do have to do a little bit of trial and error. So let's try that. What I want is enough threads here after it pokes through. There we go. That I can grab with this. And so between that washer I just put in, little seal washer and such, I need to increase my thickness a little bit, so I'm going to run that down. Okay, and I keep getting caught on that locking part for the other switch. Okay, but that should all go together now. Okay, so now I can screw on this part. Like so. And then screw the button switch on. Okay, make sure that travels well. So now, when this is ready to go, I would have my safety key in, 5, 4, 3, 2, 1, and I can push that button either with the same hand or with the other hand. Alright, and in both cases, as soon as I let go, they return to their off positions. So from a safety point of view, this is about the best setup you can have for a single position launch controller. Okay, now I need to make sure it fits in here, which it does. Alright, but there's not a lot of lip here. Okay, it's just a little bit of a lip there, so you want to make sure you get that on straight. So you do have some protection there. Now, we have two knockouts here, and what I'm going to do is use extension cord pieces for the part that goes out to the rocket, and then I'm going to use a cigarette style or a cigarette lighter style connector to supply the 12 volts going in. Now if you want, you can replace that with just some clamps, so you can just clamp them onto a battery, but I use a portable rechargeable battery that has a 12 volt socket in it, and so it just works really well to do it that way. Okay, now look at a couple other things. There's not a lot of room in here. And even here the switches go pretty far down into the base piece of the box as well. So we do have to be a little bit careful about the wiring, and it's going to be short and tight. Okay, so the nice thing is we don't need a lot of materials, but we do have to be careful that we get everything in the correct order. Next, we want to have some form of a continuity indicator. Now, technically speaking, it's not required by the R.E.A.R safety code, but it does avoid a lot of headaches later on when you're trying to figure out why your rocket isn't launching. And so, typically, when you look at, say, an Estes launcher, it just has a light bulb or an LED that, when the safety key is in, will light up if there's continuity with the igniter. I'm going to use two LEDs here. because I like to have one that shows that I've got power to the box, and then another one that shows that I have continuity. And these are also ones I found on Amazon. These are LED panel lamps, and these already have the appropriate resistor built into them. You can kind of see it as this little knob right there, so that they can run on 12 volts. A typical LED without its resistor runs on about 2.5 to 3 volts, and if you hook one of those directly up to a 12 volt source, you'll fry it. Sometimes spectacularly, they pop. An alternative is that you could use a piezoelectric buzzer as the continuity indicator as well. If you want to use a piezoelectric buzzer, you can get something like this. There are both bigger and smaller versions of this. These also I found on eBay, and as you can see, obviously from a Chinese source. The problem here in this particular project is it's going to be really tight. Okay, so yeah, you could get one in there. Okay, and you'd want to put a couple of holes in here so you can actually hear it better. But you could just use a little bit of double-sided tape or something along those lines and just attach this to the inside wall there. Now, the advantages and disadvantages here. This makes a lot of noise. Even for as small as it is, it's really loud. And some people just don't like to hear it. So this would be on all the time the safety key is in, indicating continuity. Okay. The LEDs are obviously nice and quiet, but if you're on a really bright day outside, it may be hard to tell whether or not these are actually lit. Now, these particular ones I have used before, and they're really bright, even though they only draw 20 milliamps. So we can go either way here. So in looking at these two options, I got kind of curious and asked myself whether we could put these two together, and the answer is yes. Now, to do it, you want to wire them in series, and both of these are polarized, so that if you hook them up backwards, it could burn them out, or at least make it so they don't work properly. Okay, so if we have the buzzer by itself here, okay, nice and loud, and if we do the LED by itself, as soon as I get my fingers oriented here, all right, and this is a 12 volt battery here, so that's nice bright blue there. Okay, and if we put these in series, which means you're going to put the negative lead, the black lead of one to the red or positive lead of the other here. And what this is going to do is drop the voltage across both of them by a little bit. But since both of these have a wide operating range, it shouldn't be too bad of a problem. And since they're in series, they don't draw any more current. And that's the big thing to worry about. You could wire these in parallel, but that would make could make your igniter go off during a continuity check, depending on the type of igniter you're using. All right, so now if I hook up the free positive and negative, okay, the tone goes down a little bit, which I actually kind of like. But the light is still bright, and so if you want to have both an audio and a visual indication that you have continuity, you can do it by wiring these in series. Now again, if you wire them in parallel, you don't get the voltage drop, and so the brightness and the loudness of the two items will still be the same as if they were individually used, but you'll have twice as much current going through the igniter, and for some igniters that might be enough to set them off. Alright, so I'm going to set this aside now. Now the box here has some indented areas here that are meant for labels, but I'm going to use the two square ones here as my indicator light spaces. And so this is going to require about a 5/16 inch drill bit to bore through there, and you might have to do a little reaming on it to get it to fit just right. But I'll go ahead and fit both of those in, and then probably need to take the switches out to do that safely so we don't damage them. And so I'm going to go drill this off camera and then come back and we'll continue with our construction. Okay, as you can see, I've got my holes drilled, and I just left this part in as it didn't want to come out again. That little rubber seal actually is kind of semi-permanent there, it turns out. Alright, so now I'm just going to feed these in. Now be careful, these are only set-in friction fits, so if you push on the LED here, you can pop it out of this socket. So there's a little polyethylene friction fit connector on the bottom there. Just be aware of it. If it does try and come loose, you can just put a little dab of super glue on that. Okay, but that just fits right down there. And then there's a little tiny locking washer. And that will go over our wires. At this point, I'm not doing anything to trim wires. I'll do that after we get everything in place. Okay, and then the retaining nut here goes on over that. And depending on how big your fingers are, you may need a set of needle nose pliers or something to help you get this on. Now when we go to actually hook up the wires, I'm going to use a lot of crimp connectors. So I'm going to use a multi-tool like this, and this particular one has a little plier jaw on the very front of it, and so it okay, and then you can also turn the housing itself if you like. Now here, if you let's see if we can get this to focus here. Okay, there's actually a little bit of a lip right here on the LED, which is meant so that this will go completely flush. All right, which if you just give it a little squish there, it should seat into the hole. Alright, if it doesn't, just bore out your hole slightly or ignore it. Okay, it's not going to hurt anything if it's sticking out a little bit there. So I'm just going to give this a few more turns. There we go, that's nice and snug. Okay, and I'm going to do the same thing with the other LED here. In this case, I'm using a blue and a yellow LED. A lot more typically you see green and red. That doesn't matter a whole lot as long as you know which ones correspond to which. So here my blue one will just be indicating that there's power to the unit, and then the yellow one will indicate continuity. Okay, and I'm going to go ahead and do this part off camera since you already saw one of them going in, the other one's going to go in the same way. So here I have both of my panel lamps installed, and also while I still had the switches mostly disassembled, I used a label maker to put some labels on here for power and continuity. Okay, so now I'm going to go ahead and put the switches back in. I've replaced the switches off camera, and I didn't put the actual button back on just so it's not in the way. Before I go on to putting all the wiring together, one other thing we're going to need here is an extension cord. Now if you're just going to use this for, say, low power model rockets, this 15-foot extension cord is all you need. But if you want to be able to extend this later on, if you're doing mid-power, which requires a 30-foot distance, or high power, which requires 50 feet, 100 feet, 200 feet, or more, by using an extension cord and its normal connectors here, you can make this as long as you need it. So what we'll have is, coming out of one end of this will be the socket part of this, and I'm going to cut this cord here in just a minute. Okay, so the socket part will just be on a short piece of cord and will come out of this, and then we'll plug in the plug part of it, and wherever I cut this, I will then connect alligator clips to the end, and that will allow me then to connect this to the rocket. And you can either do that directly to the end of the extension cord, or what I've done in the past is get a lighter weight cord like you would use on an appliance or something like that, and plug that in to an extension cord and go on from there. So for now, just so I've got it handy, I'm going to go ahead and make a cut here. Okay, I'm going to leave myself enough here to allow mistakes if we make them. So I'm going to cut this at about 2 feet from the socket. And for now, I'll put the rest of the cord away. Okay, and on the bottom side of this, the cord is going to go in here. Now this looks like it should be a knockout, but it does not go through the entire thickness of the plastic here, so I'm not going to just try and knock this out like I would in a regular electrical box. I'm going to drill this, and then I can put this part of the cord through. I will put a zip tie on the inside to act as a strain relief, and then once everything is where I want it, I'll also put one on this side also to keep the cord from moving. So here I have my hole drilled, and the extension cord fits through it there. I'll clean out those little shavings here in a little bit. But I want to illustrate something here, and that is you don't have a lot of room for the cord wires here. So we're going to try and keep this as tight as possible. But after saying that, you do need to have enough room so that you can open this up and still have the cord and everything attached, but not so much that you can't close it up again. Okay, so I'm going to take about, say, that much. Okay, and you want to be careful here. If you have an actual cable stripper, this works better. If not, you can use a pocket knife or something. And what I'm going to do is just very carefully score this. I don't want to go through the insulation of the individual conductors in there. So if I just score this enough that I can pull it apart, that is my goal here. There we go. Okay, so we've got conductors here, and color coding between AC systems, like the extension cord would be used for, and DC systems, like the components in here, can be a little bit confusing. Okay, because in DC systems, the red leads are positive and the black leads are negative and are usually used as a common ground. In AC wiring, the black lead is the hot lead, so that's the one that's actually got a voltage going from it to the white lead, which is the common lead, and then you have the green lead here that is the ground lead. Now, in a properly wired electrical system, these two are actually wired together at a fuse box or breaker box. In the case of our model rocket here, we're not going to use this one at all because we only need 2 leads. So I'm going to cut that off just to prevent any confusion. Now, some might argue that if you left 3 leads, it would make it easier to do cluster rockets and things like that. Yes, it would. It would also be easier to accidentally short circuit something. Okay, so now I'm going to slide this back in through my hole. And I'm going to slide this back in through the hole here, right about to there. Okay, and that gives me enough wire here to attach to the switch without having to worry about whether or not it's going to be too tight or if this is going to bunch up, because this is just long enough that when I put it together I can just fold those leads down and the switch will be connected right about in here. Now I am going to leave the zip ties off of this until we put the whole thing together. That way if I need to move anything, I don't have to cut the zip ties and redo them. All right, and we also want this oriented the way it will be when we're using it to launch. So most people are going to hold this in a hand like this, and the socket end of the power cord here should go out toward the rocket. Okay, so this will all fit together like this. Now for the other end, in this particular case, it does have a flexible vinyl or rubber knockout here. And this will be the input for the 12 volts that energizes it. Okay, and for that, I just got a 12 volt power cord here. Again, this is also from Amazon. Pretty much everything in this particular build was available from Amazon. Okay, this particular one has just a power plug and then has terminals at the end. You may also be able to find this in automotive stores where it may just be bare wires at the end. Okay, but in my case here, I just need to get down to the end. Now these terminals here are too big to fit any of my switches, so I'm just going to cut those off. And I'm going to leave a little bit of wire on them just in case I need them for something. Good for making jumpers and such. Okay, so now I've just got the cable here, and before I do anything else with those, I'm going to take my hobby knife and I'm just going to cut a little slit in here. There we go, and now I'm just going to poke this through. Okay, now we'll see how this goes back in. So I want this to have some nice friction there, so this holds it in place. Okay, and then this will tuck back into place there. And when we get this all assembled, we'll probably use another zip tie here to hold this in place as well. Alright, and kind of along the same lines as here, we want about the same amount of usable wire. Okay, and so that will all connect up here. So if you look at this schematic, what we do is connect the red lead from the 12 volt going in to the terminal of the safety key switch, and also to our power on LED. Okay, so that any time that the power is plugged in, that LED should be lit. And then from the safety key switch, we run a wire to the firing button, and also between those two, between the two terminals of the safety switch there, that's where our continuity light and our piezo buzzer go. So that when the key switch is turned on and there's continuity, then the current goes from the key switch through the buzzer and the LED to the power cord, which goes out to the igniter, comes back from the igniter and back to the common ground within the box. So basically most of our black wires are going to all get connected together at a common point. When we push the firing button, that bypasses the LED and the piezo buzzer, allowing the full current of the battery to go out to the igniter and back. And that's what's going to fire the igniter. As long as the LED and the piezo buzzer are in the circuit with the igniter, they limit the amount of current that can go through there. Okay, so now I'm going to do one other thing, and that is again to put in my piezo buzzer here. And it's just going to lay right beside the two switches here, I think. Okay, and I'm not going to do any kind of adhesion with that quite yet, because I'm not sure how loud it's going to be. So if it's going to be loud enough when the box is all closed that I don't need any vent holes, I'll just leave it that way. But it may be that I need to put a little hole in the side of the box, and then I need to determine whether having it mounted with the piezo output here going into the box, or if I need to turn that around and let it go out the hole, which one of those is going to work best. But I can do that after I've got everything wired in. Okay, so this switch is going to go from this end to this end, or you can use the other side going this end to this end. You don't want to go across like this. Okay, so I'm going to go ahead and first of all strip off this wire. Alright, and this is 12 gauge wire here, so it's fine for use with 10 amp circuitry, which is what we have everywhere else here. I'm just going to twist that together. Now, as I mentioned, I'm going to use crimp connectors on everything in here. You don't have to. You can use bare wire connections, or you can solder things. Okay, so my first circuit here is going to be this to the switch terminal here. Okay, and then we'll also connect the blue LED, which is down here, to that same wire. Okay, so I'm going to connect these two wires together, and then I'm going to connect those to the screw terminal on my switch. Alright, so here I've got a little box of crimp terminals and such. And these blue ones are probably going to be about the right size. And so the first thing I need to do here is just unscrew the one of these terminals. Okay, now, the way these are made with this little flat piece here, this is meant to trap a bare wire. So this would normally, you just unscrew this partially, you'd stick the wire in, and then screw it back down again to trap it in there. Since we're actually connecting not only this wire, but our power wire to the same thing, we're going to use a crimp connector first. Okay, so here I'm just going to extend that a little bit. Okay, I'm just going to wrap that around, and it's not even going all the way around, that's fine. But now I'm going to take my crimp connector here and place that on. And you should have just enough wire bared that you cover it up on this end and you just barely see it coming out on the terminal end. Okay, and then I'm just going to put this in the correct crimping position here. Crimp that down. Okay, and now this whole thing will fit inside here. And again, this is why I haven't done any of my zip ties yet, is because I want to give myself lots of room to flex things around. The hardest part is just getting it down in the hole there. There we go. I think it's actually a number 2. That's better. Okay, now be careful that you don't over tighten these too much, since the housings are still plastic. Okay, so now we've got our connection here to our safety key switch, but also current's going to flow along this lead, which will be connected, among others, back here to the negative lead of our power input. So I'm just going to wrap this loosely here for the moment. Okay, now what we need is a very small wire that will go from the safety switch to our launching switch. And this is a case where I can just use some of this leftover stuff here. So remember, I cut off this from the end of my power cord, and I'm going to use this to make a jumper. So I'm just going to cut off that other terminal. Okay, and then I'm going to get some bare wires on the end. And with a wire this short, you can end up pulling strands out of place. Okay, which is why this all looks all ragged on the ends there. That's all right. Okay, now again, if you wanted to, you could just crimp this into place or screw this into place using the terminals here, where you just stick this underneath that metal plate. And in this particular case, I am going to... Alright, so now I've got my jumper wire here, and to one end of this I need to connect my piezo buzzer. And get a little more insulation off of that. Okay, so this is going to connect together here, and that's going to connect into the fire button. And then the longer piece I've got here is going to go directly into the clamp connector in the switch here. Now this time, mainly just for demonstration purposes, I'm going to use an open terminal here. Alright, so I'm going to wrap that around. And then again, turn this as I put it on here. Alright, so now it's right there at the edge. I can see where it is. And I'm going to crimp this down. Alright, check and make sure both sides are in there. And this is going to go up in here, but first I'm going to put it in. So now the nice thing about this switch is it's transparent, which means I can see exactly where my wire is going. So as I slide this around, there you can see it goes right up next to the screw there. Okay, and we just clamp that down on that side. And now we're going to tuck this around. Alright, so it's going to go like that, and I want to make sure I haven't now broken my connections. And I can clamp this one down. Okay. Now for the next part, we're going to connect in series the black wire from the piezo connector to the red wire of our continuity light. Now that's a lot of wire in there that we really don't need, so I'm going to cut off about half of the lamp wire. Give myself a lot of bare wire on these two just because they're so small. So this is 22 gauge wire on these. And my smallest crimp connector is just at 22. And so one of the things you can do with this is by getting this a little bit longer, I'm going to fold it in half like this, so that there's a thicker amount of material to crimp. Okay, so I'm going to slide that in. Okay, and then I'm going to crimp that inside of it. You want to make sure you're in the metallic part that's inside there. Crimp that down. Alright, and make sure that's good and tight. And now this is going to go in the same way. So I'm just going to twist that together, bend it over like that upon itself. Okay, and then this one will go in like that. I'm going to take that out for just a moment. Sometimes it's easier to put this on the crimper first. There we go. Pull on both sides there so we make sure we've got that connected. Okay, and now this is going to be connected over here. So normally, one of our wires from the extension cord here, and it doesn't matter which one you use. I guess I'm going to use the white one here for this. Okay, so this is going to go on the other side of the push button switch, of our launch switch. There. Okay, so this would go right here on the other side of the launch switch. And remember, you want to be on, we're going across now, not over here, because this is put in 90 degrees from the other switch. Okay, so that's going to go in here, and then we also need the other side of our LED to be connected there too, so that normally when the button is not being pushed but the safety key is on, then the current is going from the safety key into the buzzer and the LED and then out to the igniter, all right, with very little current. But when we connect and push the button, then the current goes directly from the safety key to the igniter and back in. So we're going to need another terminal like we used here. So here's another one of the terminals for this gauge of wire. And again, I'm going to go ahead and cut off the lamp wire here about halfway down. We don't need all that excess wire. Alright, and then give it a good generous strip there. Okay, and then that is going to come here. Now I don't want to get a big knot of wires here, so be careful where I'm putting things. So here I'm going to wrap this around once more. I'm going to apply my terminal. Okay, making sure both wires are there. Crimping that. Okay, make sure both are still in place, and this is going to go up under that switch terminal. Okay, and as you notice, it's getting kind of crowded in here with all these wires, so be careful that you know where each one is going. Okay, so that's going to go in there, and tighten that one down. Okay, so now we've got current going from our safety switch to this side of the firing button. When the firing button is not in firing position, that current is going through the piezo and then to the lamp and then out to the igniters via the extension cord. It's going to come back from the igniter over here, and this is also going to get wired into the common ground. Okay, so I'm going to go ahead and strip this. Okay, so this wire and this wire from the 12 volt coming in, and then we had the negative wire from our power indicator. These are all going to come together. Now they don't have to be connected to anything else, so here I'm going to use another butt connector like this one. And so on one side of that, I'm going to go ahead and put on the negative part of the power light. Crimp that into place, again making sure that you're crimping the metal inside and not just the plastic. Okay, and now I'm going to put this in the other end. Okay, now that is, if I push that all the way in, we just barely covered the bare spot there. So I'm going to cut off just a little bit just to keep anything from touching inside there that it shouldn't. It probably wouldn't anyway, but it's better to be safe. Okay, and we'll crimp that one. Now before we hook this up to test the internal electronics there, the other thing we need to do is treat the other end of our extension cord. And so here I want to peel off about a foot of the outside insulation there. So just like we did before, what I want to do is just score the insulation here, not necessarily going all the way through it. And then I can bend that a bit, it needs a little bit more. You can be careful with this, as we don't want to wreck any of the inside insulation, so it's better just to do a little at a time than to overshoot and get too much. Okay, and it may be that you'll have to do this in shorter pieces. So there's a lot of friction inside there. It's not wanting to come off easily. So here we'll go ahead and come down, do the same thing about halfway up. Okay. Now, again, as we did before, we don't need the green conductor. So we'll take that out and cut that. Alright, I'm going to go ahead and remove a little bit of insulation here. We don't need a lot. That. Okay, and then we're going to attach some micro clips. These also I got at Amazon, and they are stainless steel. You can also use small alligator clips that have the serrated edges to them. Some Rocketeers actually prefer those. And these can be soldered and or crimped. What I'm going to do is go ahead and crimp them first, and then I can come back and solder them later if it looks like they need more. Now these type, they've got two little wings here, and these will just fold onto themselves. So instead of using the actual crimp connector, I use the pliers end of this. And you can do this in stages, so you're less likely to mess something up. So I just got a little bit there. And I can go on the other side. And it's hard to see this with my thumb there. There we go. And basically, you just clamp those two little wings over the wire like that, and just crimp them down. Okay, and that by itself is often enough. But if you want to, you can take a soldering iron and just run a little solder in there to get a better connection with the base of the clip. Alright, I'm going to do that with the other one as well. So once again, I don't know if you can see enough detail in the video for this or not. But, so I'm crimping over one of those two little wings first, and then I come to the other side and clamp that one down, and then just crimp them together. Okay, just like that. So now my whole extension cord goes out to my rocket launch pad. Okay, and since this was a 15-foot cord to start with, and we removed about 2 feet to attach to the box, we still have about 12 to 13 feet here of distance between my launch box and my launch pad, which gives us the recommended safety distance for low power rockets. So the plug-in part here will plug into the socket part. This goes out, and then here we have our clips for our igniters. So that would be out at the launch pad. Okay, so now I'm going to hook this up to make sure all the wiring is in place correctly before we put it together. And I'm going to take this part off camera, and I'm going to plug this into a portable jump starting battery, which you can get at most hardware or automotive stores. Okay, so this is plugged in, and we can see that we have power going to the unit. Our blue light is on. I'm going to go ahead and attach the red button here. Okay, but currently our safety key is out and off. And here we don't have an actual igniter, but I can short those together. So I'll just clip these together so it pretends it's an igniter. Okay, still doesn't show continuity, and it shouldn't because the key's not in. Okay, now if we put the key in and turn it, okay, we get the annoying beep and we get a light here. Okay, now I don't want to just press my power button with this shorted together because that would cause a short circuit, and there should be a fuse inside the plug end of the 12 volt cord there that I don't have don't want to have to go in there and dig it out and replace it. So instead what I'm going to do is attach another LED light here. Alright, now if you recall, I used the white part of the cord here as the positive side, so the black is the same color as what's used in DC circuits. Again, that's backward. If you're a household electrician, you'll know that's backwards, because in DC the red is considered hot, in AC the black is considered hot. Alright, so what I'm going to do here is attach, oops, almost got that backwards, attach black to black. Okay, and I usually wrap my igniters around like that, give them a better connection. There we go. Alright, so now I still have power. Okay, now it sounds a little bit quieter. That's because there's a little bit of a voltage drop. Alright, so no light there, continuity there, and then if I push the fire button, we get more current there and I get a brighter light. Okay, so that all looks like everything electrical is working the way it should. So I'm going to take that out, disconnect the power. Now that we know everything works, we'll go ahead and put in the zip ties here to anchor our cord. And the color you use is optional. And the only reason I'm using these longer ones is because they're also wider. Alright, but I want one right down here. You want to make sure you've got at least a little bit of the outer insulation showing on both sides there. And then I'll cut that off. I'm leaving a little bit, one so that it doesn't accidentally slip through, but also that'll help anchor it there on the inside. And then I'll do the same thing here on the outside. I'm going to reverse this. Go. Okay, I'm just going to get that right up alongside there. And then the same way, leave just a little bit of it out. Alright, so that's not going to go anywhere. And then on the 12 volt side, my little grommet here has come loose. That's okay. I will put that in just a moment. What I want to do here is make sure that all the wire gets out of the way. So we do have a lot of excess wires here. And so I'm just going to kind of tuck these around. Now remember, the power wires are going to be in the two ends there, so we don't want to put too much in the way. And a lot of these can simply fold around the sides of the switches and stuff. We just want to make sure they don't get pinched anywhere between edges. Okay, and so now I'm going to put the two halves together here, and again trying to make sure we don't get anything caught. Alright, like that. We don't want those sticking out. So if it looks like it's going to be a problem, go ahead and push things down before we close it all up. Okay, and there is, nope, there's another one. Okay, and there is just a little bit of a lip in there, and there's actually an O-ring that goes around the inside of the white portion there. Okay, so it's almost together. Okay, now just for a moment here, I'm going to take this little grommet and push it up. I'll move it here in just a minute once more. But while this is all together, and before I put the screws in, I want to check it one more time. All right, so I'm going to bring my whole assembly up here again. Okay, so I have my LED here in place of my igniter. Okay, and then I'm just going to come up here. Power shows that it's on. Okay, and actually I like that. It's not so annoying this way. And everything is still working. Okay. So now I'm going to go ahead and add the screws. These are essentially wood screws, and they're going to self-tap into the plastic, which means that you don't want to take these in and out and in and out and in and out a lot. Once they're in, it's best to leave them that way. So whatever you want to do in here, make sure you got it done. Because if you take these in and out too many times, they will strip. Okay, and I'm going to put these in diagonally to start with, so we end up with more or less even pressure. Okay, now we're going to give it one more test. And you may be thinking, well, I didn't do anything with the piezo buzzer. Well, it turns out I really don't need to do anything with the piezo buzzer. For me, it's loud enough without having any vent holes. And where it's sitting right beside one of the switches there, it's not going to have any place that it's going to move and cause problems. So we'll give this one more test. Got the power on. Okay, we have continuity and fake launch there. Now let's assume that you need a longer cord out to your launch pad, which would be the case if you're going to do mid or high power rocketry. All you need is another standard extension cord here that can handle the current. And so this is rated to 10 amps, and which is the way the rest of the system is as well. And so here I would simply take the outlet from my control box, plug my extension cord in there, and then my igniter cord would plug into the extension cord. As soon as I find the end, there it is. Okay, so now this will go into here. Alright, and my igniters, once more, would be connected to my rocket at its igniter leads. And so here, now if I do my check, I have my white LED that's filling in for my igniter again. I think I just buried the key. Oh, there's the key. Alright, so once again, if I put this in, turn the key, I've got full continuity. I can push my button. Okay, now you notice that that big red button has got some bounce to it. It doesn't always connect. Okay, you need to make sure you're pressing straight down on it and not off to one side. Okay, just something to be aware of. And with that, I'm going to call this system complete and take yours out and launch some rockets with it. Oh, not quite. I lied. One last thing that you'll probably want to do with this is reinforce this little grommet down here. And you could either do that, you can take this out, first of all, and I would go ahead and feed it in a little bit more till you get past where you put a split in it. Okay, And this is not particularly sturdy in here. I just don't quite trust it. And so what you can do here is add either some silicone rubber around this and around this piece, or a little bit of epoxy the same way, just to reinforce the whole thing, so that once it's in there, it's not going to come sliding out or breaking out at an inopportune moment. Okay, so I will do that for my own off camera, and I'm going to end this here. So take your new launch system out, launch a few rockets, and I hope you have a great flight with it.